Harwin develop, design, test and manufacture and sell through distributors high reliability and industrial connectors, and also other components for PCB boards like spring contacts, battery holders, pins, etc. So I'm here today to bring together the engineering community to ensure that you consider your connectors, whatever goes in and out of your system, alongside your system. Very often, the connectors are the last things that anybody worries about. They're so busy worried about focusing on amplifiers, mixers, filters, etc., that the connectors can often be forgotten about. So please ensure that you remember your connectors for a trouble-free or minimize the trouble of your design. And as you can see from that example board there, that connectors can take a lot of space up on a board. So we have connectors here, connectors down the side there, and connectors there. So if you kind of like judge the area there, that's probably about a quarter of the board taken up by connector space. And it can also be a bit costly as well, connectors perhaps, if you choose the wrong supplier, of course. So really it's area and space, and that all needs to be factored in. So how can connector selection affect system design? So you've spent a lot of money developing a PCB board with your engineering teams. You selected your connector, and what happens if that connector fails? Just through lack of planning and bringing the connector in right at the end. So that could be an expensive redesign. Your PCB board would need to be redesigned. That's extra time taken, and time as cost. So everything has a cost implication. So it's better to try and get a right first-time design through every component in your system, including the connectors. I don't know if anybody was in Coventry last night around 5:30. We were on the ring road, and we were involved in an incident that closed down the ring road for about half an hour. And if the guy's connection to his airbag had failed last night, he'd have been really in trouble, the guy who hit us in the back. So that's one instance where connector reliability really hits home and can save lives. So connector selection in the target areas for our components. So here to talk about really high reliability applications. So our Gecko range and Datamate range and M300 range are targets for many particular markets, one of which is the satellite market and space market. So we have connectors that are in satellites, we have connectors that are in CubeSats, and the business question around the space business is measured by cost versus weight. There's a metric that's used in the space business, and it's typically for a launch cost, it's typically £50,000 per kilogram to launch a satellite with its integrated unit and instruments and the rocket. And that can translate down to £50 per gram. And when we go down to the gram unit, that has a particular resonance with our connectors. Our connectors are very lightweight. So we'll see a little bit later how that can relate to your total unit cost and maybe operating cost of different environments. Our CubeSats are also launched from individual rockets, but also from the International Space Station. And the reason why I put a bottle of water in there is then just to see how expensive these things are to operate and to get stuff up there. So to support life with the astronauts in there, they obviously need water. So as well as recycling water on board, extra water is often taken up. And a bottle of water costs up to a minimum of $9,000 to take up per bottle. So if you think the water's pretty expensive in the centre there, it's nothing compared to what the astronauts don't have to pay, but it's associated with them. Another market that we operate in is in the high altitude UAV market. This has you see in TV, drones and UAVs sometimes have a particularly bad press. You see TV clips of US forces or the RAF maybe filming people that shouldn't be doing what they're doing and taking them out. And for the low-level UAVs and drones, the big reports around the world's airports, Gatwick and Heathrow, interrupt a lot of transport worldwide. But in the high-altitude market and reconnaissance drones, I went to the Paris Air Show this year, and it's amazing the number of applications and the number of different types of drones that are being used for commercial purposes, such as firefighting coordination, search and rescue, agricultural surveillance and monitoring. So there's a lot of applications in there that have got a lot of commercial substance to them. And also there are drones now with electric engines, solar engines, that really rely on low power and maximizing the power that they can get. And one of the metrics in this field is weight versus mission time. So it can be said, and we've heard it a few times, that just 1 gram can add 1 minute to a mission time. So if you imagine if you're unfortunate enough to end up in the sea somewhere, and there's a search and rescue operation going on, you can understand why that 1 extra minute might be the difference between life and death. So the UAV people are very concerned about the weight of components that go on their aircraft, and it really has a direct relation to mission capability. So from space to aerospace to back on Earth. So our high reliability connectors are also used in the motorsport, autosport, and Formula One industries. So everybody can really relate to Formula One. It's on TV every fortnight. If you're properly subscribed, you can see the highlights on terrestrial TV. Performance, again, dominated by weight and power, where the fine lines of qualification and victory are measured in, seconds and maybe minutes in a racetrack for 2 hours, and then tenths or hundredths of seconds in qualifying. And we all know that those qualifying positions in Formula One are very important in the sport. So we have weight that's relevant in the qualifying, and then we have weight and reliability that it relates to the main race. These cars go through high vibrations, high shocks, high temperatures during the race, and reliability is very important there as well. So we had a case a couple of weeks ago from a customer who was looking to reduce weight in their car, and they were looking at all sorts, the aerodynamics, the tyres, engine management units, the communication units, and they asked us to, obviously looking at all the board components and all that sort of thing, and they asked us to maybe take 2 pins out of a connector. So we said, well, why do you need that? It's going to take like a specialised connector, or at least a different version of it, to be supplied, and that might add to your project schedule. And they said they were looking at every aspect of the design to save 1.3 grams in a car. So that really fine margin, they still think they have some performance improvements on their competition just by a very, very small margin, to us anyway. So we talked about size, weight. This is a metric in our industry, in the connector industry, called SWaP. And there's also an acronym coming in now called SWaPC, and it's got nothing to do with swapping football cards or bubblegum cards. It's size, weight, and performance, and the C is for cost. But at the moment, as we're just technical, we'll just concentrate on the size, weight, and performance, and power. So S is for size. So we're looking to minimize the size on a PCB board. and that's the PCB footprint. So we have one of our Gecko connectors, which is in green, compared to a industry standard micro D connector. And as you can see in footprint, which is this here, and then the volume, the actual profile of the connector, you can see that the green is very much smaller than the red, put simply. And we had a bill of materials from an aerospace manufacturer who was building a brushless motor unit for one of their aircraft. And we had a bill of materials that outlined maybe 6 connectors that they wanted to replace or consider replacing on their board. We compared our Gecko connectors to the existing connectors, and for the footprint, you can save up to about 50%, 49% on footage PCB footprint on the PCB. We move to W for the swap, and W is weight. And again, for the same bill of materials, looking at the same list and connector and comparing apples to apples, we can see that when we weigh them, 84% weight saving for this particular part, and it was around 50% for other connectors on that list. So we had a really compelling in terms of size and weight, and saving money and saving cost and weight for the aircraft, boosting its performance on them moving from traditional industrial connectors to our connectors, and that's a real-life example. We also are launching the Gecko Mixtech at the show, and this part has a signal and power in it, and as you can see, the MT connector itself weighs less than a card from a pack of cards, so really, really lightweight and strong. And we go to the P in swap. So this is for your power requirements. So engineering sometimes is a bit of a compromise, and so we have a compromise here. Now the Gecko components versus the micro D components, when you load all your contacts up, we have a current capacity of 2 amps on our signal pins. For the micro D, they offer 3 amps micro pins. 3 amps on their pins when it's loaded simultaneously. So there's a compromise there, but really on a cost and weight, the Gecko is pretty good. And most of the customers don't need 3 amp feeds anyway. So it's always worth checking with your systems guys to say, well, we've got this really low weight, low size component here. Can we try and do something on that board to accommodate the 2 amps? Might be possible. It's a new opportunity for power saving. So we've seen some good practices for size, weight, and power. Now we learn good practices from bad practices. That's a fact of life. You can make honest mistakes or look at things in a different way, but we can learn from them and apply them for the next projects. So we have a team of field application engineers at Harwin that can support customers through their design, and that's what we want to do. Encourage engineering teams to come to us with any connector problems, issues, thoughts. Come to us, and our field application engineers and our technical guys will support you through your project. So these are some real-life issues that we had over the past few months. We had a customer come in to us with a list of requests, and everything seemed to be going hunky-dory for 95% of those requirements. The customer wanted 2 amp pins maximum, so we could do that with our standard connectors. They had didn't have any height restrictions. What they did want was a lot of contact positions. But But they didn't really mind how that could be done. It could be done in a dual row or a triple row. But the only connector that we had for high reliability, and that was the most dense connector that we have, didn't fit their bill. You can see there's a measurement on there, and the customer was asking for 100 contacts per millimeter. Sorry, per 48 millimeters. And that's why the dimension is there. Because this is a 96-pin connector, so to accommodate their density, we'd have really had to worked our socks off to try and get the pin contact density for a special there. Now they are available in commercially available products on the market, but not for high rel. So if they'd have come in and said, maybe early in the project, we're having this issue, we want this, we could have steered them in a different direction. And I'll show you an example of how we did that in the next example. So we had a client come to us, and they said, can you get us a 120-way connector in the Gecko range? They were all using Gecko connectors, so they bought into the Gecko concept. We only offer 50-way connectors, so we said it'd have to be a special, a custom build. How's that going to affect your project schedule? And it would have affected it quite a bit, and also the extra cost of developing that and the customer paying for that. So we said, can you provide us a drawing so we can take a look and maybe suggest something else? So they provided us an outline sketch, and what it is that there's the green is a PCB board. This was the projected 120-way connector. With this is a housing, so the PCB board was sitting in a housing of height X, and then there was cables coming into the connector from here, here, and here. And these are fictional connectors, or fictional components on the board, which all add height and width, just the general shapes there. Obviously, the customer didn't give us the full picture of the board, protecting their IP. So we engaged our FAEs to take a look at that, and they came up with this solution, which benefited us and benefited the customer. It was a Harwin-win solution. So we had 3 of the Gecko, and these were all off-the-shelf components immediately available to the client, so they could immediately order those connectors in and put them on the board, albeit with a little bit of a redesign. The design itself, from the previous slide, was a lot cleaner. No wires going over the top of the existing components on the board. So it was a neater design. It was easily better serviced because they didn't have to go in and loop all the way around the wires and take those out if there was a problem with any of the components on their PCB board in the future. And also, they didn't have to pay the extra cost and development cost maybe and wait for the project schedule of the 120-pin connector. So as I say, it was a win-win. And also, without all that cable, okay, we'd sold 3 Geckos instead of 1 connector in there, but the customer won as well because the weight advantage as well. The cables had gone. And also, you can imagine with the cables floating around the top of those components, there could also be some interference going on from the cables to the board. So that was gone as well. That's a way that we can work with customers and bring an optimal solution for the board and the connector. We also come up with homebrew modifications from customers. In this case, the customer was again in the UAV market, and they wanted to save weight, which is brilliant, which is what they should be doing. They took one of our datamate connectors and thought to themselves, well, we can save weight here by taking out the guide pins of the connector. And when they were mating the harnesses and the boards together, they were getting some misalignment, and the pins were shorting and affecting their battery life. So again, a little bit of compromise. Always think about the reliability of your end product before thinking about weight as well. So it's all an engineering compromise, really. But as soon as those guide pins came in, the connectors fitted perfectly, the battery life was preserved, and the endurance of their UAV was tip-top. Be careful about the project changing requirements, goalposts moving throughout the scope of a project. Again, as I said earlier in the presentation, the main components, as people perceive them, amplifiers, filters, etc., inductor coils, might have, in some people's eyes, a lot more importance than the connector, but it shouldn't be like that. Your connector is part of the system. So you really need to cover all aspects there. And even in the, and don't forget these solutions are also in 3 dimensions. So we have X and Y for the PCB board, but we have the Z direction for any housings or modules that these boards are going in. So think about how you're going to screw down your connectors. Is there room for a screwdriver to get in there? If you have requirements to screw down connectors, is there room for a latching tool? So think about that as well. Some common issues that we also find is incorrect hardware for the application. So for high rel, we have a number of fixing options for connectors. So these could be connectors that are with no latch on at all, so they're soldered onto the board. So if it's mount technology, for extra strength and shock and vibration absorption, you can fit them with latches, locking latches, or you can have screw down. There are a number of screw locking mechanisms that you can use as well. So we had one customer that had a latch connector on the board, but when it came to servicing the board, latches need a specific tool to unlatch and get the connectors off. And even though the engineers had the correct delatching tool, they couldn't get access in the correct angles to take the connector off. So the customer was saying, well, have you got any alternatives? And luckily we did. We had a 101 screw lock gecko that they used, and that was an instant fix, more or less, where they could change their connector with a little bit more of a PCB increase and footprint, but the serviceability for their product was increased, and the customer was happy with that. Also, don't think about your power, your current, and your voltages. If you have a fully loaded module, if everything's running at the same time, then temperature rises, and that's why you have to think about derating currents and power. And we have lots of technical data on our websites for particular modules, connectors, pins that we can look at for you. And also we have the technical team on site that can go in and do any special measurements for you, given time. Another common mistake is think about what might happen next when you put a system together. We know that PCB board is tight, space is at a premium, but we had a customer with a radar system where they had wiring between the radar and the power bus, and they found that on one of the connectors there was some interference from RF and EMI interference, and they needed to implement a back shell housing. But when they came to it, they didn't have enough room to put it in that space there. So always think about maybe putting a little bit more space around your components, or at least thinking about it. If that happens, how can we get around it? Another one is miscalculating the costs. We offer crimp contacts, single power leads. So customers can either have an engineering team that put the crimps and the contacts together and the wires together. That means that they own the yield on that. They also have to buy specific tools for putting those together. and they own the reliability. Harwin can provide ready-made cable assemblies. So we own the tools, we own the staff, we own the quality, and that has to be factored in. Maybe on the surface, maybe a little bit of a cost difference, but on the whole of the system, you know you're getting a reliable product delivered to you. That has to be considered also. So this is a few, and it's something difficult for a supplier to approach, but you know we're all an engineering team here. So some of the common mistakes of actually coming in late to us is the supply chain. We have a franchise distribution, so does the engineering team and the company that they're working for, do they know of our distributors? Have they got links with our distributors? Think about the schedule impact if that component isn't available. And pick an odd size, finish, or a pin length at your peril. They may not be stocked, so you may have to wait for them to be built. So please, I mean, as an engineer, you don't know whether that's an odd size. You see it in a catalogue, you don't know, it must be okay. But, you know, there is a family or a series of pins that are very popular and some that are not so popular. So again, engage with us early so we can sort those issues out. So in your design, your early stage considerations, think about the electrical properties that your connector needs to face, maximum currents, maximum voltages, maybe the time that your voltage is on, the duty cycles, and also think about the frequency of operation. Are you pure DC? Are you AC? Are you going up into radio frequencies? Think about EMC. We do offer some small cans for PCB board components, but also consider your connector, what's around there, what's the isolation between pins on the connector, isolation between radiating pins maybe on the board to the connector. Consider those sort of things. Consider your mechanical environmental area for your end product and what your end user's doing. Spoke about the space industry, Formula One, aerospace, so there's shock, stress, and thermal, vibration, temperature, and what kind of environment is it? Is it at sea level? Is it up in the air? That can affect all sorts of things. If it's in space, think about your thermal conductivity. How are you going to get the heat out of your board when there's no molecules up there for convection taking the heat out? Think about the design. We talked about potential homebrew improvements. I say improvements in inverted commas sometimes. Think about how your connector's going to mate with each other. How are they going to be aligned? We provide 3D diagrams for customers, so you can import them into your drawing tools, and you can see how those 3D symbols, volumes, drawings interact with the rest of the design. Standards and compliance. Is your supplier ISO registered? Do they have good quality systems behind them? Also think about your local and your worldwide regulations, shall we say. So the ROSH REACH certificates for the actual material that your connectors are made of. Are they allowed in the market that you're approaching? California has a separate environmental agreement than the rest of the US. People say, have you got this for California? Well, we have those on the website, and we also have a compliance team that can help you with those sort of aspects. And also if your end product needs to be UL fire rated for plastics. And also there's conflict materials as well. So smelting plants and how the materials are governed around the world, how are they extracted? Are there people being, I wouldn't say abused, but are they being mistreated because they're in a particular mine? that sort of thing is governed and is regulated. So how to specify with success? After all those things, engage us early, check the stock, ask us, this is what we're here for, ask us for advice, we can guide you through your design. We can help you with the distribution network, who best to go to, but also engage your product teams and your, supply teams on getting the right connections, and we can help you with that. And just don't design in from a drawing without doing your homework. So I mentioned earlier that we're launching the Gecko Mixtech device. Come and see us on our stand. We have samples that you can request. So this addresses really a lot of the items that we've talked about with the swap. So it's the power for the Mixtech is 10 amp and 2 amp. It's one of the lowest, smallest and lightest connector out there. It's tested over G-forces, stress, vibrations and temperature. It has a small pitch, 1.25 millimeter pitch. Operates to 150 degrees C with various locking mechanisms. And you can get cable assemblies for it as well with back shells. And we also offer a white paper that we can help you get enabled with. Ask us to get that connection to you. And this will help you go through a choice of connectors, or choosing your connectors wisely, really. So there's a 3-stage document there that you can download and work your way through that will help you. And this includes a specifying checklist as well. So it will help you to design your connector correctly in your system and engage with us early. So thanks very much for listening. We are in J54, our booth. Come and see the men and women in black. I was told to wear white because of the backdrop here, but we'll be in our black t-shirts and we're here to help. So thank you very much. Any questions?